This is another question that College Board posted for AP Physics 2 for practice. You can find this question on our College Board quiz Board quizzes. We probably will do this in the classroom if we have time. If we don't, you have it here. And let's read the question. So try to solve it actually first before you see my explanation for this question. So pause, try to solve it, and then watch my explanation. So the circuit contains 4 identical 10 ohm resistors. Calculate the current through the battery. Rank the current in each resistor from greatest to least. If any resistors have the same current, indicate that explicitly. Use physical principles to explain your ranking. And then for C part, the capacitor is now added to a circuit below resistor 4 as shown above or on our right. And the circuit is allowed to reach equilibrium. Indicate below how this affects the current in each of the resistors. So I redrew the circuit for you, and the current is going to flow from positive to negative. Some of it is going to split this way, some is going to go that way, and the rest is going to continue. It looks like here the circuit, the current is going to be added from these 2 branches, and then this current is going to be back to what's left from the battery. So let's calculate the total, because they ask you to find in A, calculate the current through the battery. So it's not through specific resistor, it's the total current. It's this current, the one that is leaving from the battery. And the same current is going to be coming back to the battery. So we're trying to calculate this current. And I'm going to be using Ohm's law. V is equal to I times R. So this is my main formula that I'm going to be using. But I need to find the total resistance first. So I always start with parallel resistors if I can simplify them. So I have 2 parallel resistors. Parallel resistors, they share 2 nodes. So if you ever see 2 resistors connected to the same points, 2 points, those resistors are connected in parallel. So here I always do my calculations for total resistance is 1 over, so it's 10, plus 1 over, another 10, and that gives me 2 over 10. My result flip over, so that's 10 over 2 ohm. So my total resistance of these 2 resistors is going to be 5 ohm. So I'm going to redraw this circuit as I have this 1 ohm resistor, or 5 ohm resistor. I'm just, instead of these 2 resistors, I'm going to have just that 1 resistor. Then I'm going to have still this resistor, which is 10 ohm. Then I still have this resistor, which is another 10 ohm. Oh, and by the way, I'm writing my resistors in engineering way, not the way physics books show them. So physics books show you resistors like this. My resistors are like this. It's easier for me to draw this way. So I have this way to complete my circuit. Also, these points, the red ones that I drew for you on the circuit, these are these points. And I'm going to do different color, maybe let's do gray. And I'm going to do this color, 2 gray points. I'm going to keep them right here. Okay, so now I see there are 2 resistors in series. So I have 1 resistor and another resistor. And they are connected in series. What means in series? It means when the current is going to go, some of it went this way, but this, think about this way. Current is like measured in amps, and we're going to say they are aliens. So some of the aliens will go this way. They will pass through this bridge, join the other aliens that went the other way, join them here, and all of them will come back right here. So when they pass over the bridges, they have to pay. How much do they pay? So initially they start with some voltage, I'm going to call it EMF. And every time they pass through the bridge, they have to pay some of the voltage. By the time they get home, they have no voltage left in their pocket. So it's the same current that is leaving, coming back. And the voltage, every time you pass this bridge or the resistor, you give away some money or some voltage. So I see these two resistors, I'm going to make them with the crosses, are in series, and when I have series connection, I just add them. So instead of those two, I'm going to rewrite one resistor, and I'm going to put the cross right here, and another resistor that I have here. Oh, let's keep it the same colors that we did the whole circuit. So I have this resistor, and then I have another resistor that I made green now. And again, the longer side of the battery is positive and the shorter side is negative. And here is my green resistor. I have only the gray dots left, or the gray nodes connections. I lost my red one because I combined these two resistors together, and instead of those two I only have one. So I do still have this point because it's the same as that point. So I still have this point and that point, but I lost the other red point on the top. So now what I see are two resistors in parallel. Oh, and if I combine those two resistors, that gives me 15 volts, or 15 ohms. So every time I have resistors in series, I just add them. And so now I see two parallel resistors. So I can do again 1 over, result flip over. Let's choose a different color. Let's do orange. So I'm gonna combine these two. I'm gonna say 1 over plus 1 over, because the other resistor, the green one, is still 10. The common denominator is 30, so I have 2 plus 3. So I have 1 over, my result, flip over. So that gives me 6 ohm. So now I can redraw my circuit as, let's keep it orange. So I have orange resistor, which is 6 ohm. Then I have the rest of my circuit. And they give you what the voltage is. The voltage is 12 volt. So your EMF right here is 12 volts. So that means the current that is leaving the battery is 2 amps, because V is equal to IR, I is equal to V, which is 12, divided by R, which is 6, and gives me 2 amps. So I know that the current that is leaving the battery is 2 amps, and it's going to be the same current that is coming back, 2 amps. Then let's look back right here. So I know that this is now 2 amps, and the voltage is given 12 volts. The first resistor, the green one, or this resistor, or this resistor, the first one, the first resistor is connected parallel to the battery. So this is where our gray points were. So this is where our gray points were, and this is where our red points were. So the first one is connected to the battery, straight to the battery. That means that the voltage between the gray points is 12 volt as well, because it's just connected straight to the battery. So if I want to find the current that went this way from here, Then all I have to do is divide 12 by the resistance of each is 10. So that gives me 1.2 amps. So 1.2 amps went this way. That means that way 1.8 amps. Because I divided 12 by 10, I got 1.2 amps over there. So 1.8 went there. They have to split this 0.8 has to split some here, some there. But I know here is going to be the same 0.8 amps. So the voltage drop between this gray point and between this red point is V equal to IR. R is still 10 ohm, and 10 times 0.8 gives me, so the voltage dropped here is 8 volt. Also, when the aliens or amps are leaving the battery, this is how much they have to spend. So those that went, let me choose different color right here. Those that went, keep it green. So those that went this way, they will spend all 12 over here, and then you return back home. So 1.2 aliens went this way through the first resistor, pay 12 volts, and come back home. So they only had 12, they spent 12, they come back home. The other ones also have to spend 12. So they will spend something here, then the rest looks like 8 is going to be spent over here, and then back home. So if they spent 8 on this branch, they must be spending 4 on this one and 4 on this one, because it doesn't matter which path they're going to choose. They can go this way, 4, spend 8, back home, or they can go this way, 4, 8, back home. So they have to spend 12. So now if I know that between the red points there is only 4 volts, so between this point and this point there is only 4 volts, then I know if, because resistor is 10, voltage divided by the resistance, voltage divided by resistance will give me current. So I have 4 divided by 10, so 0.4 amps will go through this resistor, and 0.4 amps will go through this resistor. So you had 0.8 that went this way, after 1.2 went that way. So 0.8 goes this way, and then they split into 0.4, 0.4, combined together, 0.8 on the top, and then this 0.8 will join the other 1.2, and together will be 2 amps that are returning back home. So the answer for my B would be the highest current, so they have to rank the current for each resistor. So I1 is the greatest, and then you have I2, then you have I2, which because it's 0.8 amps, and then the next one, or maybe we'll just do this way because usually they have this way. So I1 is the largest, then I2, and then you have I3 is equal to I4. And for C part, they say a capacitor is now added to the circuit below resistor 4 as shown in our circuit on the right, and the circuit is allowed to reach equilibrium. Indicate below how this affects the current in each of the resistors. When they say that the circuit is allowed to reach equilibrium, that means the capacitor is fully charged. If the capacitor is fully charged, then the current does not go through this part. So I will redraw the circuit for myself right here. So I have resistor 2, resistor 1, and I have resistor 3. It looks like 2 and 3 are now in series. You still have this dot and this dot, or not and not, and you still have those gray ones as well. But my resistance between this point and this point, they are connected in series because the same current is gonna go for them. I can replace them with one resistor of 20 ohm because each is 10. And then I have the gray dot, 10 ohm resistor, and the battery. So the total resistance for these two parallel ones is going to be 1 over the common denominator is 20, so it looks like it's going to be 20 over 3. So now I have 20 over 3 ohm, 1 over, the result flip over. So I combined, so this is my gray dot and another gray dot. Now my gray dot is still there, but I just combine all the resistors that are left in one circuit. So the current is gonna be now different. I have this current is equal to the voltage divided by total resistance. So that is 36 over 20, which is 1.8. So the total current of the circuit dropped when the other resistor was disconnected because of the capacitor. So if the total current dropped, this one, let's place it back. This resistor will still have the same 1.2 amps through it because the voltage is still 12 and the voltage between the top and the bottom gray point is still 12. So 12 divided by 10 gives me 1.2 amps. So it looks like even though 4 is being disconnected from the circuit, resistor 1 stays unchanged. So it remains the same. Resistor 1 is going to remain the same. Then for the second one, if 1.2 went this way and there was only 1.8, then that means 0.6 is going to go this way, 0.6 amps, because total I had 1.8. So I have 1.2 amps this way and 0.6 amps that way. And I did not mention why the resistor 1 is going to have the same brightness. Well, you understand the voltage is the same, the current is the same, and the power formula is I times V, or I squared R, or V squared over R. If I use this formula, IR, to replace my V or replace my R if I solve for R, this formula. So it's one of those. So because the voltage is the same for the first resistor, the voltage is the same for the first resistor, and the current is the same, the brightness is going to stay the same. So what's left again in the other branch is 0.6 amps. That means through resistor 2, you're going to have 0.6 amps. And let's look what we used to have. We used to have, I'm going to make it in orange. We used to have 0.8 amps. Now we have only 0.6 amps. So it looks like my resistor 2 decreases its brightness because, again, I times R, resistor did not change, but the current dropped. so I'm gonna have less brightness there. And now I have 6 volt is dropped over here because I times R, and R is 10 ohm. I times R gives me 6 volt. So when the current aliens leaving, they carry, or there's actually 1.2 aliens, 1.8 aliens leaving, right? 1.8 aliens leaving. They will pay $12 or 12 volts between these 2 points. That's what they pay every time they pass the resistor. That's how much voltage is dropped. They will play 12 volts on the first resistor and return back home. So that's going to be their branch right here. But the other guys, 0.6 of them went this way, and 0.6 are going through here, and 0.6 are going through here. They have 12 volt to spend. They're spending 6 on the top resistor too. That means they have to spend another 6 volts on this resistor. So coming back right here, that means between these 2 points, I have 6 volt. That means I have, compared to before, I had 0.4. Let me do it in red. I had 0.4 amps, and now I have 0.6 amps going through this resistor. So before was 0.4, now 0.6. Again, looking at this formula, there is more current going now through resistor 3 than before. So resistor 3 increases the brightness, and resistor 4 is off. So that means resistor 4 decreases its brightness because there is no current flowing through resistor 4 after the capacitor was added into the circuit. And that is it for this question.